Welcome to your 7.5 video on log properties. Kind of like exponent properties, logs also have similar rules that we have to abide by in order for the math to work. Now, officially, here are your properties. Okay, there's three properties we need to live by, and one's a product property, one's a quotient property, and one's a power property. Okay, so from the top it says let b, m, and n be positive numbers such that b is not equal to 1. Okay, so let's look at the product property. When you look at it, it says this, log base b of m times n. Okay, when you look at log base b of m times n, okay, you should be able to see that m times n is really a multiplication, m times n. Okay, so what it's saying is if I have two things being multiplied together inside the log, okay, that is equivalent to taking the first one and adding the second. Okay, so when you do log base b of m times n, it's like splitting it apart and putting a plus sign in the middle. Log base b of m plus log base b of n. Okay, quotient property is very similar. Okay, when you have two numbers being divided inside the log. So in this case, I'm right in the middle of the screen. I want to have m divided by n. If I have two things being divided, that's the same as splitting them apart and going ahead and subtracting them instead. The top minus the bottom. The m is on top, subtract the n that's on the bottom. Notice that the b's stay the same, no matter which one you're in, whether it be a quotient or the multiplication or product property. Okay, you notice that the bases stay the same. So the bases shouldn't change. We just have an idea that now if we have multiplication, that really means add. If it's division, that sounds like subtract, which is not a whole lot unlike what we've done with exponents either. And then finally, the power property is if I have a number to the nth power or to some power, hey, what it's saying is this. I can take that n, that power, and I can throw it out front. Okay, so if I have something like this, instead of being log base b of m to the n, that's equivalent of throwing the n out front and going n times log base b of m. So the n is no longer even in the log, it's just out front being a multiplier instead. Now, your next slide looks something like this. Okay, I'm not going to worry about it for now. If we actually need to go ahead and talk about it, we will. But for right now, let's go ahead and avoid this slide. And if we have time tomorrow in class, we'll go through it. But I'm least concerned about this slide. Let's look at this one instead. Let's do a few of these and make sure we actually know how to do with these log functions. Look at number 1. It says log of 6 minus the log of 3. First of all, we really know it's log base 10. When we only have log, we know it's base 10. So it's log of 6 minus log of 3. Well, if I go back to that previous screen, I know, looking at that second line, if I look at that second line, I know, and I'm right here, right where I'm making that green star, that if I'm going ahead and subtracting two things with the base being the same, I can go backwards and I can really put them back together, okay, and really make a division on them. So make sure we can go both ways. So realistically, if I come back to this problem, I know that really is the same as log of 6, the first, divided by the second. Well, that's really log base 2. And it tells me in my instructions that I want to match up 1, 2, 3, 4 to A, B, C, D. So I think this one matches up with B. Let's try number 2. You see out front there I have a 6 and I have a log 3. So if I put it back together, okay, I know this number really came from really being the power, and I'm really looking at the power property. Again, if I go back to this one right here, you can see that the number out front, again, I'm on this third one right here. Okay, I know that if I have a number out front, that really is, if I go backwards, that really is the power of the number inside the log. Okay, so if you come back to here, that really is the same as log base 10 of 3 to the 6th. And if I look across without really needing to simplify much further, I think that is C. Look at number 3, same idea. Now in this case I have a 3. I'm going to put that thing back out on top. So I think I have log base 10 of 6 to the 3rd. And I think that matches up with A. And hopefully 4 lines up with D. Let's check it out. If there's a plus sign, if they're split apart with a plus in the middle, that really means multiplication on the inside. Okay, so I really have log base 10 of really 6 times 3, which I think is log of 18, which sure enough is B. Let's look at the next slide. Okay, they're going to ask you two things tomorrow in your homework. They're going to ask you to expand, and they're going to ask you to contract. Okay, so when I look at something like this, okay, when I look at number 1, I have log base 5 of 4x. In this case, expanding means I want the sum or difference of multiple log functions. Okay, if I condense it, condensing means try and get it down to the least number, and most of the time it's only one log. So in this case, I want to expand as many as I can and go ahead and get rid of all the possibilities. So now I see I have log base 5 of 4x. Well, I know 4 times x, there's a multiplication inside. If it's a multiplication, I really can split it apart and say, hey, this is really log base 5 of 4 plus a log base 5, or excuse me, log base 5 rather, log base 5 of x. So when I look at that, I don't think I can go any further. There's nothing more I can go ahead and split apart, and I've expanded it into as many logs as I possibly can. Okay, number 2 is similar. If I look at number 2, that's the natural log of 20x. Again, I see that's natural log of two numbers being multiplied together, so I think that's equivalent to the natural log of 20 plus the natural log of x. Again, multiplication implies addition, and division implies subtraction. Like the next one, look at number 3. I have log base 4 of 7/9. Well, if this is division, that's really the same as subtraction when I split it apart. So I really have log base 4 of 7 minus the log base 4 of 9. Now, again, you might ask, why am I stopping there? Well, there's nothing more I can split apart. I can't go ahead and split those numbers apart any more than I already have. Okay, and so I'm just going to go ahead and leave it just like that. Okay, if you look at number 4, I have a couple things going on. First of all, I have this 4x squared. I know I have two things being multiplied together, so I have log of 4 plus the log of x squared. Multiplication implies addition. But then I also see this squared right here. I know I can simplify that. If there's a squared inside the log, I know I can throw that thing out front. So I really have log of 4 plus 2 log x. I've completely undone or expanded everything that condensed it to one log in the first place. Look at number 5. If I look at number 5, I have, again, two numbers being multiplied together. So I really have log base 4 of 3 plus a log base 4 of x to the 5th. Again, I see that power in this one, so I'm going to throw that out front. So I think I end up with log base 4 of 3 plus 5 log base 4 of x. Now, number 6 is going to be the one that causes the most issue. Okay, I'm going to try and create a little more space. So I'm going to try and kind of section off a couple here to make sure we kind of keep this as one, because it's good to go ahead and try something a little bit harder along the way. Okay, first thing I see is log base 7 of two things being divided. Dividing means subtraction. If you need to go back and look at your notes, please do that. Okay, so I really have this. I really have log base 7 of 3x squared minus log base 7 of 5y cubed. Now, if I look at the first log, I see a 3x squared. I see two things being multiplied together. So I really have log base 7 of 3 plus log base 7 of x squared. So that really took care of the first log. But then the second one said it was really a minus a log of 7 5y cubed. So I have minus the whole quantity. There is multiplication on the inside. I know I'm adding. So I have log base 7 of 5 plus log base 7 of y cubed. Notice I'm putting them all in parentheses because I'm subtracting that entire quantity. Now, let's go ahead and keep going. I see a lot of stuff I can simplify, especially powers. I'll do it in a different color. I see an x squared right here, and I see a y cubed right there. So I'm going to go ahead and simplify that. So if that's the case, I really have log base 7 of 3 plus, I know that 2 is going to come down right here, so I really have 2 log 7 of x minus, if I distribute that negative, I really have a minus log base 7 of 5. But then I also got to give it to the other one as well as bring the 3 out front. So I really have a minus log base 7 of y. Pretty crazy one there, but I took one log and I turned it into 4. What if I go the other way? What if I take a look at this and I say, hey, what if I have a whole bunch of logs and I want to put them back together? So if you look at number 1, for example, I have log of 9 plus 3 log 2 minus log 3. Okay? Take 2 at a time. Doesn't make much difference which 2 you take. Okay, but take 2 at a time and start simplifying. For example, if I take the first 2. First of all, I see this number. I know I can go ahead and put it back to the top. It was a power, and I want to put it back together. So I really have log base 9 of log of 2 cubed minus log base 3. Now let's go ahead and combine them. So I really have log of 9 times 2 cubed is 8, so I really have log of 9 times 8 minus log of 3. Well, 9 times 8 is what? 72. So I have log of 72 minus log 3. And if it's a minus sign, I know I can put them back together because a minus sign implies division. So if that's the case, I have really log of 72 divided by 3, and that is really log of 24. Notice I've been able to take all three of those and condense them back into one. Okay, let's try number 2. If I look at number 2, first of all, I'm going to try to put stuff together. I see the 2 right there. I'll put it back on top. So I have natural log of 8 plus the natural log of 5 squared minus the natural log of 10. Now if I put 2 together, I really have a plus. Plus implies multiplication. So if I look at natural log of really 8 times 5 squared is 25 minus the natural log of 10. Well, 8 times 25 is what? 200. So I have a natural log of 200 minus natural log of 10. And then subtraction implies division. So I really have the natural log of 200, the first, divided by the second. And if it's natural log of 200 divided by 10, I really have the natural log of just 20. Now, if you look at number 3, again, a lot of the same process here. If I see a 3 out front here, I'm going to try and put it back together. So I have the natural log of 4 plus the natural log of 3 cubed minus natural log of 12. If I do that, I really have the addition implies multiplication. And so if that's the case, I really have the natural log of 4 times 3 cubed is 27 minus the natural log of 12. Now, 4 times, if I go ahead and simplify that, 4 times 27 should be the natural log of 108 minus the natural log of 12. Let me move this little sign here so we can go ahead and have enough room. And then division or minus implies division. So I really have the natural log of 108 divided by 12. Let me write that a little bit better for you. If I have the natural log of 108 divided by 12, and when I take 108 divided by 12, I think I end up with the natural log of 9. Notice the goal here is when I condense these things, I want to put them back together and try and get down to 1 log or 1 natural log if I can. Let's do one more. Let's do the 4th. If I look at number 4, again, I see it's a 1/4 power. I'll do it in a little bit different color so it doesn't get combined with the one above. I have 1/4 here. I'm going to go ahead and put it right back to the top. So if that's the case, I really have log base 3 of 4 plus really the log base 3 of x to the 1/4. Okay, I've been not very careful in the last problem because they've been either log base 10 or natural log. But in number 4, notice the bases are the same. I can't do this if the bases are the same or not the same. So the fact that they're both base 3 allows me to do this property. So if you look at this, the addition implies multiplication. So I really have log base 3 of 4 times x to the 1/4 power. In this case, there's not really much else I can do except for put them next to each other because there's not anything simplified. I can go ahead and reduce and make even simpler than it already is. Okay. Let's try a little bit more complicated ones. If I look at number 5, I have a whole bunch of stuff going on. First of all, notice I have something that looks like 2 plus signs. If I have 2 plus signs, I know I'm doing a lot of multiplication. Again, I'm going to first start looking at, is there any kind of power out front that I can put back as a power, put back inside? For example, I can put the 5, I can put it back as a 2. I can take the 7, I can go ahead and put it back as the x, and I can put the 4 back as the y. And if that's the case, I think I end up with log base 4 of 2 to the 5th plus log base 4 of x to the 7th plus log base 4 of y to the 4th. Now, if I were to at least simplify that first log, I think I have log base 4, 2 to the 5th is 32. So log base 4 of 32 plus the log base 4 of x to the 7th plus log base 4 of y to the 4th. Now start simplifying. Now start putting stuff together. Okay, I'm going to take those 2 logs right there, put them back together. So I really have log base 4 of addition implies multiplication, so 32x to the 7th. Okay, still got that plus that log base 4 of y to the 4th. And the only thing left again is another plus. Another plus implies multiplication, so I really have log base 4 of 32x to the 7th y to the 4th. Again, inside there's not much more I can go ahead and simplify. I've reduced it down to one log. It's been done. It's accomplished. And I think number 6 is actually pretty straightforward. Okay, if I have a 2 out front, I can go ahead and put it back together again. So I really have log of y squared plus the log of 12. And one more time, the plus sign implies multiplication. So I really have log of y squared times 12. And we know by now when we have numbers and variables, usually you put the numbers first and the variable second. So the nice easy way to put it is log of 12y squared. Okay, tomorrow on your homework, you're going to be asked to condense and expand. Expand means get as many logs as you can. Condense means get it down to 1. The last thing we're going to talk about today is a change of base formula. Again, at any point you can go ahead and pause this video so you can go ahead and read through this. But here's the problem. Here's the issue. When you look at your calculator, okay, and I'll bring my calculator across here. When I look at my calculator, see if I can grab it here. The problem with your calculator is that it only does logs. You can see that right here when you press the log button. Okay, it only does log, and we know if it just says log, we really imply it's log base 10. So if that's the case, your calculator only allows you to do log base 10. The issue with that then is this. If I go back to the green screen, kind of in the white space, if I say go ahead and calculate something like, if I go ahead and calculate, I'm going to get my pen back out. If I have something that log base 6 of 4, there's no way for you to calculate that with a calculator. The problem is because your calculator is only programmed in base 10. And so we got to have some sort of formula to go ahead and reduce that so we can go ahead and actually use our calculator to our advantage. Okay, and so that's what something they call the change of base formula. Okay, let me go ahead and tie my calculator at least for the time being. Let's go to the change of base formula. Change of base formula says this. Okay, it's right here. Okay, and I'm grabbing this right here. Actually, I'm going to go ahead and clear that and go ahead and pull it back up so you can actually see it. If I look at something like this, here's my change of base. What it's saying is this. If you have some sort of log, and I'll call it log base C, of some kind of number that I'll call A, what I can always do is I can always take the log of, and I'll say this is going to be base 10. I'll say B is going to be 10, even though it's always going to be the case that you can use any log you want. Okay, what you can do is you can do log base B of A divided by log base B of C, which really means you're going to take the log base B of the big number, the A value, and divide it by the log base B of the C. Okay, again, B, I'm going to go ahead and say is log base 10. Okay, so my base will be 10, and really all I'm going to do then is take the log of the big number divided by the log of the little number. If that's the case, it's going to make my life so much easier because now I can go ahead and find any log that I want using my calculator. So, for example, and before I move on, notice it doesn't have to be 10. You can also see here, if I have a log base C of A, I could also do natural log. Okay, it doesn't make any difference really what log you choose you want to convert it into, as long as you take the big number A and divide it by the old base C. Okay, for example, if I look at something like this, okay, if I have, and it says, hey, I want to evaluate log base 6 of 24 using common logs. Okay, when I look at something like this, there's no way to type it in. I can't type that into my calculator. Okay, and so instead what I can do, and I'll use common logs first. Common logs would be the 10, the numbers, versus natural log, which would you be using E. Okay, if I want to say, hey, I want to find log base 6 of 24, with a base of the base change or change of base formula allows me to do is say, okay, I want to take the log of the base that I want to convert it to. Well, what do I want to convert it to? I want to convert it to log base 10. So just for sake of argument, I'll put log base 10. And what I want to do is I want to take the division of the big number, 24, and divide it by the old base 6. So I'm going to do log base 10 of 24 and divide it by log base 10 of 6. Okay, if I do that, that allows me to use my calculator because now I've converted everything that I want. I've converted it all to base 10. So if I want to go ahead and evaluate log base 6 of 24, all I'm going to do is then take log, which is really log base 10, of 24, divided by the log of base 10 of 6. Okay, when I get that, I hit enter. I should get 1.775. 4 roughly. So if I come back to my problem here, okay, I know I have roughly 1.774. Now, to illustrate my point, I want to also do it with natural logs. It shouldn't make a difference. I chose to change it to base 10 because I know my calculator calculates base 10 as well as natural logs. Okay, so what if I do exactly the same thing? What if I want to convert log, try and get it back to here a little bit, there we go. What if I want to do log base 6 of 24 and want to convert it to natural log? Well, that just means I'm going to take the natural log of the big, 24, and divide it by the natural log of the small, which is 6. Okay, but the cool thing is, if I go ahead and bring my calculator back over here and do exactly the same thing, but just use natural log instead, know what happens? Natural log of 24 divided by the natural log of 6. When that happens, look at that. I get exactly the same thing. I still get approximately 1.774. It doesn't make any difference what base you chose. It makes no difference. Okay, as long as you take the log or the natural log of the big number, okay, divided by the natural log of the old base or the small number. Okay, so let's try and go ahead and do something. I'll go ahead and hide my calculator. When I look at something like this, I want to use a change of base formula to actually evaluate. So have your calculator handy so that you can actually calculate it. Yesterday, if I asked you to find a log base 5 of 8, you'd have no idea what to do. It couldn't do it. Okay, the change of base formula allows me to do it. So if that's the case, all I want to do, typically we do base 10. Okay, we can do something else, but it seems base 10 is the easiest. So I know I can just do simply the log base 10. I don't need to put base 10 because a log signifies that. So log of 8 divided by the log of 5. It's as easy as that. Bring back my calculator. I'm going to do the log of 8 divided by the log of 5. And when I hit enter, I think I get approximately 1.292. Okay, if I go on to number 2, log base 8 of 14, again I'm going to take the log of the big, 14, divided by the log of the small, 8. Go back to my calculator. It's really this simple, folks. Log of 14 divided by the log of 8. Hit enter. I think I have approximately 1.269. And then finally, the last one, if you already haven't gotten the point, log base 26 of 9, I'm going to do a log of 9 divided by the log of 26. One more time, the log of 9 divided by the log of 26. Hit enter, and I approximately get 0.674. Okay. Tomorrow we'll talk a little bit more and wrap up any kind of change of base formulas and work a little bit more on log properties. I'll see you tomorrow.